Okay, this time we have our topic wherein we have this integral that involves logarithmic and exponential functions. So this is our basic formula to find the integral that involves logarithmic and exponential functions. So first formula we have here the integral of du over u, which is equivalent to ln u plus c. And then we also have the integral of e to the u du equals e to the u plus c. And of course, the integral of a to the u, for this part, we have a to the u du equals a to the u over ln a plus c. So all we have to do is to follow this particular formula. So take note in our previous topic, or in the discussion about definite and indefinite integral, we have this formula. Take note, we have integral of du, which is equivalent to u plus c, and then we also have our formula, the integral of u to the n du is equivalent to u to the n plus 1 over n plus 1 plus c. So we have this formula for our definite and indefinite integral. Now we will proceed with the integral involving logarithmic functions. So basic example for this particular formula, we have, let's say, example 1. Okay, we will have here example 1 using the integral of du over u, which is equivalent to ln of u plus c. This formula du over u, you are only allowed to use this one if the exponent of your denominator is 1. However, if the exponent of your denominator is not 1, say for example 2, 3, then you will be using u to the n du. So for this case, take note, you have your exponent, the whole exponent of your denominator must be equal to 1. Therefore, you can only apply this formula. So say for example 1, example A. So we have here, I will rewrite this one. Okay, so example A, we have examples. Letter A, let's say integral of dx over x, or 2x. So if you have your 2, then you have to write first 1 over 2 and separate your numerical coefficient, and then you have your dx over x. So if you have noticed, this is du over u. Our u here is x. Derivative of x equals dx. Therefore, we can make use or we can apply this formula. So we have here 1/2, and then this dx over x, that is du over u, or ln u plus c. So we have ln of x plus c. Okay, another example, we have the integral of 3 dx over 4 plus 2x. If you have noticed, your exponent of your whole denominator is 1. Okay, so we will be using, for this case, we will be using this formula du over u, wherein our u, for this particular problem, our u equals 4 plus 2x, 4 plus 2x, and then its derivative, that is equivalent to derivative of 4 plus 2x equals 2 dx. If you have noticed here, this is 3x, 3 dx, and then we also have here 2 dx. Okay, so the only difference is this number 2. With the presence of number 2, this one is dx, and then this one is 2 dx. So again, we can make use of this formula if the difference only is a number or the sign, negative or positive. No? So we will rewrite this one 3, the integral of, we will, instead of dx, we will write here 2 dx. Okay, instead of 2dx, instead of dx, 3dx, dx, we will write 2dx. Since we write here 2dx, then we will write here its reciprocal, that is 1/2. This is under use substitution from my previous video. Okay, divided by 4 plus 2x. So for this case, that is 3 times 1 over 2, that is 3 over 2, 3 over 2, and then the integral of this 2dx, that will be our du, which is 2dx, right? So du divided by our u for this one is 4 plus 2x, 4 plus 2x, so that will serve as our u. Therefore, this one equals the integral of du over u, that is ln u plus c. So this 3 over 2, we will copy this 3 over 2, and then ln of our u is 4 plus 2x plus c. So this will be our final answer for this particular problem. Another example, we have here letter C, integral of, let's say, dx over 4 minus 3x raised to 4. If you have noticed this one, our denominator, the exponent, is raised to 4. So for this case, we cannot use du over u, this formula. We cannot use or apply this formula because the exponent is not 1 for your denominator. This one, this problem, our exponent is raised to 4, it's not 1. Therefore, we will be using other formulas. So for this case, we will be using u to the n du. So if we will use this u to the n du, then we will make this denominator as your numerator. So rewriting this one, that becomes 4 minus 3x raised to negative 4 dx, which is then equivalent to, you have to identify what is your u. Let u equals 4 minus 3x, and then du, that is equivalent to derivative of 4 minus 3x, that is negative 3 dx. So if you have noticed here, you have negative 3 dx, and then this one is it's only dx. Okay, this is only dx, so that means this formula is applicable for this particular problem. So we will continue. For this case, you have here negative 3. So we will rewrite this one as the reciprocal of 3, negative 3, that is negative 1/3. The integral of 4 minus 3x raised to negative 4, and of course this negative 3 dx. That means we have a negative 1/3 integral of this one will be our u, 4 minus 3x, and then this exponent negative 4, that is n, and then our negative 3 dx, that will be our du. So that when you solve this one, that is negative 1/3, and then the integral of u to the n du equals u n plus 1. We have here our formula, n plus 1 over n plus 1. So you have your u, which is equivalent to 4 minus 3x, n plus 1, that is negative 4 plus 1, that is negative 3 over negative 3 plus c. So that our final answer, this is negative 3 times negative 1/3, that is positive 1 over 9. And then this is negative 3, so to make it positive, we make it as our numerator, the denominator. So 1 over 9, and then we have 4 minus 3x raised to positive 3 plus c. That will be our final answer for this particular problem. Now, another example, letters D. For example, letter D. Okay, integral of 2x dx over 3x squared plus 1. If you have noticed here, the exponent of x is 2. However, the exponent of your whole denominator is 1. So for this case, of course, you have to think before you solve this integration or integration problem, you have to think first of the formula which is applicable for this particular problem. So let us say we will be using the integral of du over u. So if we use this formula, we have to identify our u. Our u is equivalent to 3x squared plus 1, and then du equals 6x dx. If you have noticed, we have here x dx, and this one is x dx. So they have the same integrand. So that means this formula is now applicable for this particular problem. So rewriting this one, you have here, I will write first 2, and then instead of writing x dx, I will write 6x dx, 6x dx, and then since I write here 6 instead of x dx, I will write its reciprocal, that is 1 over 6. And then we have here, just copy this one, that is 3x squared plus 1. So that is equivalent to 2 over 6, that is 1/3. And then this one is of course du, I mean ln u. ln u, that is the derivative. Okay, I will write here 6x dx, take note that is our du, and then our u equals 3x squared plus 1. So 1/3, and then integral du over u equals ln of your u, which is 3x squared plus 1 plus c. Okay, so take note, we have here x dx, so 6x dx. Now another example, we have here letter E, which is our formula. Take note, integral of du over u, integral of e to the u du, which is equivalent to e to the u plus c. So we will have an example for this particular problem. The integral of 2e to the 4x dx. So if we want to use the formula e to the u du, then we have to check our u. Our u for this case, that is 4x. And then the derivative of u, that is equivalent to 4 dx. Notice this is 4 dx, and then we have here dx. So again, we can apply our formula. So this one is equivalent to 2, I will write first 2, and then the integral of, by copying this formula, e4x, and then instead of writing dx, I will write here 4 dx. And if I will write here 4 dx, I will write the reciprocal of 4 here, 1 over 4. So 1 over 4 equals 1/2. 1/2, and then e to the u plus c. Okay, take note of this one. This is e to the u, and then du. Our du equals 4 dx. And then we have another example, EF. Let's say the integral of 3 raised to 4x dx. Okay, this formula, we can, this problem, we can make use of the formula, which is integral of a to the u, which is equivalent to a to the u over ln of a plus c. So we have to identify first our u. If we make use of this formula, integral of a to the u du, then our u is equivalent to 4x, and then the derivative of u equals 4 dx. Again, this is 4 dx, and then this one is dx. So the only difference is this number 4. So we can make use of this formula. So if we have here 4, then I will write here its reciprocal, 1 over 4, integral of 3 raised to 4x 4 dx. We have this one. So this is now a to the u over, a to the u du. This is our a to the u, this is our du. So that when we answer this one, you have 1 over 4, and then a to the u, that is a to the u, which is 3 to the 4x divided by ln of our a for this one is 3. So we have here 3 plus c, and then that is equivalent to, if you have a number here 4 ln 3, that is equivalent to ln of 3 raised to 4. So that means 3 times 3, 9 times 9, 81. So our final answer is 3 raised to 4x over 3 times 3, 9, 81, ln of 81 plus c. That is how we use this formula, a to the u du. Supposed to be, we have here du. Okay. So fg, last example, we have here the integral of let's say 3e to the 2x minus 4 raised to 2x dx. Okay. So when we distribute our dx, that is equivalent to 3 integral of e to the 2x dx minus integral of 4 raised to 2x dx. So that when we integrate e to the 2x, our u, for this part, our u equals 2x, our du is equivalent to 2 dx. So notice this one, this is 2 dx, and then this one is dx. So we can apply our formula for e to the u. Okay, we'll transfer this one. Next, how about this 4 to raised to 2x? Again, our u equals 2x, du equals 2 dx, and then this is only dx. So again, we can apply a to the u. Then our final answer will be 3. Of course, this is 2x. Our u equals 2x. Then we have here 2 dx. So the reciprocal of 2, that is 1/2. Integral of, the reciprocal 2 is 1/2. Integral of e to the 2x 2 dx. Take note of number 2. Its reciprocal is 1/2. Okay. And then this one, 4 minus 4, integral of 4, our u equals 2, so we have to write also the reciprocal of 2, which is equivalent to 1/2. So 1/2 integral of 4 2x dx. Remember, this 2x equals our u. Derivative of 2x equals 2. So we will have here 2 and then 1/2. Okay. So our final answer will be 3 over 2. And then this is e to the u. That means e to the u, e to the 2x minus this one is 1/2. And then a to the u, that is 4 raised to 2x over ln of 4 plus c. Now this is 1/2 ln of 4. 2 ln of 4 is equivalent to a ln of 16. So that we have here, we will arrive to our final value, which is 3 over 2 e to the 2x minus 4 raised to 2x all over ln of 4 squared. 4 times 4, 16. That is ln of 16 plus c. So that will be our final answer.